right, it seems like it's time to get started, everybody. So thank you very much for coming out. I know it's already a little bit late here, but I hope you're having a great reInvent. I've already talked to a few of you, and it sounds like it's been going really well. And today we're here to talk about a topic that I'm pretty excited about. This is something that we've been talking to a lot of SaaS providers about over the last couple years, and that's SaaS extensibility. Specifically, our title here, supporting extensibility in SaaS, right? So we're here to talk about this at a somewhat high level today. This is going to be a 300-level session. In other words, we're not going to be able to get down to the code level and actually show how to do some solutioning. We're going to stay just one level above that. We're going to talk about some architecture. We're going to look at some examples of SaaS providers who are doing a great job already building extensibility into their platforms. And then we'll get down and we'll look at a couple examples of different ways you can build extensibility into a SaaS platform. So my name is Bill Tarr, and I'm with the AWS SaaS Factory. And we help provide best practices on building SaaS to AWS partners. So I hope you'll enjoy the rest of the session with me for the next hour. Let's start off with a simple definition of what extensibility is in SaaS. And I know people don't like it when you use the word to define itself, but it really is a process of extending your SaaS platform. And the how of you do this is really the interesting part. You take your SaaS platform and you bring in external developers to help you build features around the edges of your SaaS platform. And you do it without changing your core code base. And that's really the center point of what extensibility means. Another way to think about this is when we often talk about configuration over customization in SaaS. In other words, you don't want to be reacting to every new tenant situation and every new context by changing your code base and changing anything inside the code itself to have tenant-specific code. Rather, you want to keep this one pure code base and configure it for all of the different contexts it needs to operate in. And that's, in a sense, a lot of extensibility is about. It's a new version of doing this and a new way of building on top of SaaS. Why does SaaS extensibility matter anyway? And I'll answer my own question, growth. We're going to look at extensibility as a growth model for SaaS. And we're going to think about different ways we could implement this model to achieve that growth. And before we get to the why, we're going to have to start with the what. What are we talking about here? What are some of the underlying details about how we're going to build out an extensibility solution? And we'll start with our core SaaS product. Over time, we start with an idea. That idea, we work with our customers, we work toward product market fit, and eventually we develop a laser focus on what that SaaS product is and what we're trying to achieve with that SaaS product. But inevitably, after we build this SaaS product, our customers are going to start coming to us and say, we want this specific feature. We want these set of features that meet our use cases. And as SaaS providers, we want to be customer obsessed, but it's very difficult to build all of these custom features into our SaaS platform. So perhaps we start off by building a public API. And that public API certainly is a part of our extensibility story. So we can expose some data APIs, customers can extract data out of our system, and perhaps they can connect to some other systems that they're using. So this solves some of the use cases of these customers who want these specific features, specific use cases that appeal to them. But it shifts a lot of the burden of operating those features onto your customers. So let's look at a couple other communities of users that we could look at to help add to our extensibility story, to make it a little more robust on our customers' behalf. And the first group of users I'll identify might be community builders. And community builders are builders who are outside of our immediate circle. So these could be other companies that we want to partner with, that perhaps we have customers in common with, and they can contribute features from their platforms to our platform. But they're not really going to be inside of our immediate circle of influence. They have their own interests, and we have to partner to find the commonality that we want them to build. And what they're going to build, we're going to call community apps. And we're all familiar with apps. You have a phone in your pocket right now that has an app store on it. Your computer has an app marketplace on it. And this is very similar to that in a lot of ways. Your SaaS application will now have some form of marketplace where customers can select and say, I want to install this specific feature or application. And I don't want to get lost in the word application because when we think of apps, we often think of a UI-driven experience. And for SaaS, that may or may not be true. In many cases, we might have a UI-driven experience, but this could be some form of an ETL or a data process or some sort of AI/ML process that's going to run off of our SaaS solution. So even though we're going to call these apps, it's a nice shorthand but it could mean a number of different things in terms of business processes. And in addition to these community builders, we're also going to explore another set of builders. We'll call these internal builders. Internal builders are more inside of our circle of influence. Perhaps we have a contractual obligation with them. Perhaps we sign an SOW with them, like a solutions integrator, and say, we want you to come and build this specific feature for us. Or again, perhaps an external company that we, instead of having them just contribute an app, we want to work with them to help scope out and pay them perhaps to add an extension to our application. So these extensions, we're going to explore how those are a little different from the community applications that we've already mentioned. And we're going to have some form of extension management that's going to be part of this solution. So given all of these apps and extensions being added onto the edges of our SaaS solution, we're certainly going to have some complexity added in terms of how do we turn these on and off individually? How do we allow different roles, for example, our customer success team, to turn those off and on our customer's behalf? What is the different ways we can think about this extensibility story in terms of managing the extensions themselves? So finally, I started off with growth, and let's think about, from our customer's perspective, what it means to have grown our product. If we can achieve these applications and have different partners contributing apps, if we can have these extensions added inside of our application, we've certainly grown the overall feature set of our SaaS solution. And potentially, we've also grown our total addressable market. We now have different customers who couldn't have used our platform before, who now are able to use our platform. So we've grown our total addressable market, our overall features to help retain our customers, and hopefully, we've also grown our bottom line as well. And of course, there's going to be challenges with extensibility. And those start with the tenant experience. As SaaS providers, we fought hard to make the tenant experience as good as possible, reliable, available, secure. Now we're introducing new and different ideas to the customers. These applications that from their perspective are part of your application, or extensions that they see as features in your applications. How do you make sure that their tenant experience is consistent with what you fought so hard to provide for them? And what does it even mean to trust code contributions? We're talking about code that comes in from external parties. What do we have to do to validate that this code is something we can put in front of our customers? How do we check that the experience is something that would meet our customers' expectations? And then finally, and this is maybe the biggest one from my perspective, how do we maintain the agility that we've achieved by going to a SaaS platform? How do we take all of these different things that we've learned how to do, our DevOps best practices, our developers and the focus that they have on the features they're developing, and our business processes that know how to appeal to our customers with a specific feature set? How do we keep these agility points that we've attained with SaaS in the face of adding these apps and extensions on the edge of our application? And there's something of a tug-of-war here between the agility we're trying to achieve and the flexibility that's the promise of an extensible platform. And I'll lay out some of these factors for us. In SaaS, we want to keep a single code base. Going back to what we talked to about configuration versus customization, this single code base is the focus of our core SaaS application, and we don't want to lose that focus in the face of adding custom features into our application. These features might be turned on and off tenant by tenant, tier by tier. How do we keep the focus of this simple application and not overbalance to a point where we're adding these custom features and now our core team is chasing after these features rather than our core feature set? How do we keep the resiliency and availability that our customers expect with our solution in the face of third-party integrations? A lot of these applications and the extensions that we're going to create are going to call out to third-party APIs, and there's certainly going to be code that's from third parties. How do we keep our overall platform experience as our customers expect it? And that DevOps story. We fought hard to get zero downtime into our applications, continuous integration and deployment. How do we take our best practices as we know them for delivering our application and keep those intact while introducing these independent life cycles that all of these application developers are going to need? If you're going to build an application for this SaaS provider, how are you going to be able to independently release your own application without having to worry about what my practices are in DevOps? How are we going to be able to allow your application to continually flow out while my features are continually flowing out to my customers? So let's switch gears and start to think a little bit about this community extensibility story. So we've talked about community extensibility in terms of the people, the builders who are developing these apps on our behalf, being somewhat outside of our circle of immediate developers, and them having a lot of independence in terms of the way they develop. So let's take a look at the marketplace and examine a few SaaS providers who already have excellent stories in terms of extensibility, and think about how they've implemented these different models. Because extensibility isn't just one type of solution. There's actually a number of different ways extensibility can be implemented, and a lot of those depend on how you implement your actual SaaS product. So hopefully you recognize at least a couple of the logos up on this screen. They're all good examples of SaaS to start off with. Everybody knows Slack. I assume you know a lot of these other logos as well. It's certainly a case of them having different models that allows them to have different types of extensibility. So let's explore each one and look at how they've built extensibility, and then think about how we might implement extensibility on our own. We'll start off with Slack, and I'm going to come back to them in a couple slides. But they're a great example of workflow orchestration. So we'll want to think about how we might be able to want to implement workflow orchestration and allow more complicated workflows than just a simple function that functions inside of our application. Twilio Segment's another really interesting example, and I would put them in the category of extension as a platform. In a lot of ways, Segment, which takes source data and connects it to a source destination for that data, allows you to create extensibility that lives in between with functions that you can contribute that transform that data in some way. But beyond that, each of those destination sources and destinations are also apps that you can contribute to Segment. In other words, your entire flow of how data moves from one place to another in Segment is part of an extensibility story itself. It's a very flexible model. Freshworks, and we'll focus on, they're a whole suite of products, but I'll focus in on Freshdesk, one of their products. And Freshdesk you can think of as a customer support tool. And I like them as an example of using extensibility to connect different business processes, but keep those business processes independent. Because those customer success tools, like a customer success ticket, will produce information coming in from our customers that we're going to want to inform other teams of. Product teams, developer teams, and those teams use different tools. So they've created an extensibility story that in Freshdesk, when a ticket is updated, you can add any form of function in between that and any external solution, like a Jira ticket, for example. So when the ticket inside of Freshdesk is updated, the developer teams that are relying on that data can get that data in whatever form and format they require that data to continue their own processes without relying on the processes of these customer support teams. And finally, Stripe apps are a great example of an app marketplace. And we're going to dig right into that example now. So let's start talking about what that looks like. Most of you may be familiar with Stripe. They're a payment processing platform. And of course, security is paramount to much of what they do. So when they built their app marketplace, they wanted to reach out to customers who had different types of functionality than what they could themselves provide, or rather, what was the core focus of that payment processing platform. And as you can see from some of the logos here, these are very different industries than Stripe functions in. So let's focus in on one of these and take a look at the Intercom app that they built for the Stripe app marketplace. If you think of yourself as a Stripe user inside of their UI, and you can imagine as a payment processing platform, if you haven't seen their UI, there's customer information in there, there's payment information, there's subscription information in there. Whatever context you're in inside of that UI, when you open up the Intercom app, it will bring that context into that UI, and it will pull all of the information from Intercom. And Intercom is a customer relationship management solution. So that information could be relevant to your customer, any conversations you've had back and forth with them, relevant to their subscriptions, and whether they should be renewing their subscription at this time. All of those things come in the context of the Stripe app and where you are in it at this time. And behind the scenes, how they implement this, we talked about APIs before, and APIs are the cornerstone of all of these different flows for extensibility. And the Stripe APIs will expose customer information and subscriptions, payment information. But importantly, they've made one decision that I think we're going to revisit a couple times, and that's hosting the back end of this application on Intercom's infrastructure. So this is a choice that we'll revisit and talk about how different providers have made different decisions. And those Intercom servers host whatever backend, however they want to build it, And Stripe has simply provided the APIs and the webhooks to allow them to call back in from their infrastructure. And there's a three-way conversation here between those APIs and the apps and those intercom servers that allows them to exchange information, and pull in all of the information from intercom in the context of where you are in your Stripe application. And before we leave the Stripe example, one of the first things Stripe said when I talked to them about their extensibility experience was how important the developer experience was for making a successful app marketplace. They have a number of different tools. I just want to highlight 3 of them. So as we're thinking about building our own extensibility solution, we can think about the type of things we might need to build in to enable developers to enjoy building on our platform and want to build applications and contribute to our app. And the first of those, as I said when I started, Stripe's a payment processing platform, and so security really is the cornerstone of what they do. So they wanted to make sure that that security was reflected in those applications. So familiar to you if you've installed any applications on your phone, permissions are presented to you when you install an app through the Stripe marketplace. So that's a common experience, but the important part of this from my perspective is they provided these nice tools for the developers to not have to understand all of those permissions at once and try to understand and code what those permissions would be needed by the application by providing a simple CLI experience. Stripe apps grant customer read. Plain English, easy to use, and you can install those over time as you're developing your application and realize you need access to certain APIs. And they've got a rich SDK experience. The developers, of course, anyone who's developing in the room understands that SDKs abstract out a lot of the complexity that underlies any system. And these Stripe APIs, even though they're well documented and easy to use, still have complex flows, like customer create might have to go and see if a customer exists, retrieve it if it does exist, create it if it doesn't, handle any specific errors and whether a customer might be enabled or disabled. They've encapsulated all of that in a single line of code to make it easier for you to simply retrieve a customer and not have to worry about what Stripe is doing behind the scenes when you're writing your application. And finally, authorization flows. So this is an example of a PXE flow, private key certificate exchange flow. You don't have to worry too much about the details of this. But it is important to think about what the developer experience is when they're implementing a flow like this, because these flows are complicated. If you've dealt with OAuth before, it's not a simple subject. And we can't count on the developers who want to contribute these applications knowing all of the intricacies of these flows. So what they've done is they've documented these flows carefully and provided the exact code examples for each one of these steps that you would need to implement on your Stripe app, taking away any of the undifferentiated heavy lifting of learning how to build these Stripe flows. And also, another interesting aspect of this, they've added what they call the Stripe Secret API, where at the conclusion of this flow, when you get an access token, you can store it onto the Stripe's hardware. So this sort of blurs that line between the hosting models we were talking about. But importantly, you don't have to now worry about the security of storing tokens. You let Stripe handle that part of the flow, and it simplifies the overhead that you need to think about if you're going to host your own applications. I said I'd switch gears and come back to talk about Slack. And when we talk to Slack about their extensibility story, the first thing out of their mouths is building blocks. And I love this term because if you're going to build an extensibility flow, you should be thinking about how you create these flows as simple as possible. And they define their building blocks as starting with triggers. And those triggers are exactly what you'd expect. They're listening on events from your Slack UI, like perhaps a new message coming in or emoticon, and also for more complicated flows, like a webhook coming in from a different system. And it allows you to trigger workflows. And workflows are quite simple. And in fact, if you use Slack, go into the workspace that you're in, go to the tools menu, and you'll find a workflow builder. So anyone with very little or no code experience can go and create this low-code builder block experience that allows them to create these workflows with a number of different steps. And today, you could go create some simple flows within Slack without any code at all, or you could contribute specific functions that allow you to do things within these steps, like reach out to the Stripe API or Slack API and retrieve data, and act on the rich data and create more rich applications and better flows. And importantly, revisiting the hosting question, Slack has decided to host this on their own infrastructure. Now think about the type of developers that Slack is targeting here. You or I could go into Slack today and develop an application. We could distribute that application to our companies, and our whole company could start using it. And potentially, we could distribute that to other companies, and this could become an application available in a marketplace. So if you're going to go down this road in terms of targeting specific builders who may not have the ability to host their own infrastructure, it means you're really going to have to take on the burden of hosting this infrastructure on their behalf. So now let's switch gears and look at what it might take for us to build our own community application and a marketplace to distribute it on. So we'll start with our typical any company builder, and they're going to provide an application for this SaaS provider. The SaaS provider has a simple use case of being able to host photos, including branding images and company outings, for any of their tenants. But any company has a massive data bank of all of the metadata that's geolocated to any of those photos. And in fact, they already have some customers in common. So those customers today have to go and retrieve that metadata, upload it manually into the SaaS provider's application. So they want to build a serverless app that they can upload onto this new app exchange that the SaaS provider is going to create. And finally, of course, the tenants of the SaaS provider are eager to simply get this into the UI and be able to create the common overlap between this metadata and the photos that they already have in the SaaS provider's application. And as you can imagine, as we think about the growth potential of extensibility, both of these companies have the potential to introduce new customers to one another. So it's not a single direction where the SaaS provider is trying to grow their own solution. Potentially, any company could also achieve growth by having some of the SaaS providers' companies start to use customers start to use their platform as well. And what does it mean to contribute code that we don't necessarily know and trust that's coming from the community? And it starts with your local development environment, perhaps an IDE, in some cases, an in-browser development experience, an IDE that's inside the browser. But regardless, at some point, this code is going to have to be contributed up into the platform. And from there, the SaaS provider is going to have to take a few steps to get this from where it's uploaded and to where it's hosted and presented to our customers. And those might start with validating the code, right? How do we confirm that this code is worthy of putting in front of our customers? How do we package it and host it? What's the model that we're going to use to deploy these out into some of our infrastructure? And finally, this is a SaaS application. So what does it mean for us to create the tenant isolation around each of these entities that we're creating? Each of these applications is going to have its own isolation story. And we're going to have an operational story as well. Just like we operate our SaaS platforms today and emit all of the metrics and logs out, aggregate those, and be able to deaggregate them, we have to think about these apps through that same lens. How are we going to operate not just our core SaaS platform, but now all of these apps that live around it successfully? And this process is going to start with publishing our applications. And that publishing the applications, a reasonable place for uploaded code to land is S3. And from S3, we're going to kick off our typical build processes. We'll propose using a code pipeline. And then first, we might start with a build process that'll kick off some compute to record the state of the application that was uploaded. Because if you think about it, you're going to have to be able to track these things over time. What S3 bucket did we put it in? Who's the tenant who is the builder who uploaded it? What's the name of the app? What version are we on? Because eventually there's going to be a day 2 story here as well. What happens when 1.3 comes in and we have to deal with that version? We're going to have to maintain a list of these things, and we're going to have to build that over time. And we might need a manual approval process as well. Simply put, this is the point where we get to what do we do with untrusted code? What do we do with code that's coming from sources that we can't validate until we look at this code? And it might involve a human process. So we might provide this code reviewer with different tools like the outputs of Lint, perhaps Amazon Code Guru. And we might give them different tools to allow them to get some automated output. But at the end of the day, we still want a pair of eyeballs to review this code, looking for any malicious code, looking for any known vulnerabilities, and any unexpected experiences that we can already see in terms of this code. And finally, we kick off our infrastructure as code, which is good. We'll say CloudFormation for this case. It really could be anything for this particular example. But it will kick off our test environment and our prod environment. And if you paused and said, oh, wait, we didn't even test this yet, how's it going out to our prod environment? I thought we wanted to validate this code. And for now, we'll just assume that this code is completely isolated. And then in fact, our tenant isolation model is going to prevent anybody from being able to interact with this code, and our customers won't see it until later on in the process. And we do need this test process, and it might involve an app reviewer team. And this app reviewer team would be responsible for confirming a number of points: the UX of the experience, the architecture of the experience, the context of this application inside of our overall SaaS provider UI. What happens when you click around and open the application in different contexts if you allow that. So all of those different things we need to validate. And we also have to go back to App Company and say, hey, you guys should come in here and test this too. Make sure the things that you are building are consistent with what you see now in our UI. And eventually, we'll make something of a naive choice here and say, well, at this point, a tenant should be able to go and install this application. And if you thought, well, there might be different tenant isolation models here where we wouldn't be able to onboard a customer so simply, then you'd be correct. In a couple slides, we'll come back, we'll revisit tenant isolation, think about what that might look like, and we'll come back to this story and look at onboarding again if you have different models that in fact might involve more infrastructure. For now, let's take a look at how we could package up this application and some of the pieces we might have to contribute in addition to what the builder has contributed. So now we have a Lambda, right? Our code that the customer contributed, which doesn't do anything in this case. If anyone who's trying to figure out what the code does, this is just an example of code that was contributed by one of our builders. So we wanted to represent it and show that it will land in a Lambda, which has the ability to reach out to our core APIs and access data from our core systems. But we're going to have to build some pieces around that. So I'm going to propose using Lambda Extensions, and particularly external Lambda Extensions, which implies that these extensions we're going to contribute live longer than the execution of the code that the user contributed, because they can run in a different process, and we'll see why in just a second. But first, we're going to do a tenant management extension. And this tenant management extension's responsibility is to make sure any calls that come into this app have the tenant context passed into it. Who's the tenant who's currently executing this application? Make sure that that tenant has permission to use this application. And then also, any calls out back to our APIs, that tenant context is injected into those API calls so that the APIs can make their own decision. Should this tenant be allowed to call this specific API, or did something go horribly wrong and somehow the wrong tenant is calling one of our APIs? But I mentioned that we were going to use a longer-lived process, these external Lambda extensions. And that's because we're going to run a metrics manager and a logging manager. These are going to require a longer execution time, potentially, than our core solution, because we want to make sure all of those logs and metrics flush out of our Lambda before it terminates. And our tenant context is going to be passed indirectly from the tenant manager that we've created. So we're going to use our extensions, it's going to pass the tenant context, and it's going to use this tenant context to pass that off to some cost analytics solution. So as you probably realize, if you're operating a SaaS solution, you need to be able to have visibility into the cost per tenant story. What does it cost to operate any specific tenant in our solution? But now it takes on a new level of complexity. We have to think about the cost of our applications and the cost of operating those tenants for those applications. So we need to emit metrics, something like this. This is a very simple example of using Lambda execution time to calculate the cost of this Lambda. So we said this Lambda took 2 seconds to execute. We can reach out, we can use our book prices and calculate that out. We could go to our cost and usage report, retrieve that data, get the exact cost if we have used provision currency, for example. These are the type of things we need to think about as we're building out a cost model. And we need to be able to pass this information to our business, potentially back to the builders, and even potentially to charge our customers. And we also have to think about the developer experience again. How are these application builders going to be able to iterate over these applications? What's the experience that they need to look at to be able to say what errors have happened with our application? What's the operational footprint? How is this application actually operating, and to continue to improve this over time? The same tools that we need to provide to our internal SaaS developers, we need to provide to our application developers, because the same expectations are going to be put on them. That the application should continue to improve, and over time, new versions should be introduced. And without those inputs, how are they ever going to build those? And I said we'd come back to isolation of this serverless application. And we have some different choices. But I'm going to make one choice up front that's going to influence all of the other options that we're going to look at. We're going to run our applications in a separate AWS account than our core SaaS product. To me, this is a fairly straightforward decision for implementing a simple code isolation between our core app and serverless, and these serverless apps, because it's easy to make. And all of the different isolation models that we choose in there allow us to further create granularity of tenant isolation in those accounts. So let's take a look at what this might look like, starting at the very edge of our SaaS product, where we're going to make a call out to these applications. And it might be as simple as a routing Lambda. Then this routing Lambda will have perhaps a DynamoDB table that tells it where each of the Lambdas for the specific tenant live. And we'll take a look at what that looks like in a more complicated scenario on the next slide. But this routing is simply going to say, hey, I know to call out to this specific Lambda for this specific case. So what are some examples of tenant isolation we can use to house these applications? And yeah, I did skip over there. You know, you're going to have IAM, of course, in place here, and it's going to have a cross-account role. And that will really come into play for this first model, where we're going to do runtime isolation. So I'm not going to have time to go into dynamic policy generation or token vending machines. If you're not familiar with those concepts, we've written and talked about them elsewhere. But at a very high level, we're going to share the same Lambda for all of our tenants in this model. So at runtime, we're going to take in the tenant context that we've been talking about, perhaps a JOT token that says this is the tenant that's executing the Lambda at this time. And we'll use that to scope access to anything that this Lambda reaches out and touches. In the case of this model, that's not anything. But what if we had a DynamoDB table or an S3 bucket that this Lambda could reach? We can create an IAM policy that says at this execution, this Lambda can only reach the bucket that this tenant is allowed to reach. So this is one choice, but it's not a very conservative choice. We don't know a whole lot about the operational footprint of this Lambda and this application at this point. So maybe there's some more conservative choices we'd want to take a look at. Perhaps per-tenant infrastructure might be another choice. So in this case, we're still using this external account, and it's still shared for all of our tenants. But each one has their own Lambda. And this is a reasonable choice, right? So we still have some issues we'd want to think about, like noisy neighbors, right? There's still a potential that one Lambda could eat up all of our provision concurrency, and our other tenants could suffer because of that. And there's certainly quotas and limits that could come into play. We've got a shared account here. You know, what happens if we run out of API gateway requests per second if we are using an API gateway? What happens if, again, we're using up our provision concurrency? So all of these different pieces can come into play in this model. So is there something even more conservative, a completely silo model we can consider? And of course there is, or I wouldn't have said it, right? We can do an account per tenant, right? So we can have this account per tenant model where each of these Lambdas, for each of these extensions, lives in a different AWS account. Now there's trade-offs to this. This is obviously a very conservative model that creates complete tenant isolation around each of these tenants' experience. We've removed noisy neighbor concerns, and it's simplified in a lot of ways for the tenant's experience. But for our experience, there's going to be a lot of operational overhead. As you can imagine, we're going to create a lot of accounts if we have a lot of tenants. So there's certainly trade-offs that we'd have to make in terms of going in this direction, but it's not an unreasonable model. And in fact, some of the SaaS providers we've talked to who are doing extensibility are picking this model because it is the most conservative model, and they don't want to introduce any of those concerns about tenant experience into this app experience. So, as I mentioned, the onboarding story gets a little bit more complicated if we were to do something more conservative like an account per tenant model. And that might look like this. So now we have two different tenants trying to install our application through our app exchange. We're going to have to kick off another process that takes the output of the code build that we were doing before, the code pipeline, and takes that and puts it into an S3 bucket. So we can do that with a Lambda, right? We package up a zip file, we load it into that bucket, but now we're going to have a piece of compute that's our onboarding Lambda. And this onboarding Lambda is going to kick off our infrastructure as code and write a DynamoDB table that keeps track of which tenants infrastructure is deployed where. So you remember when we were looking at that routing Lambda before? This is that DynamoDB table, right? So it's got to keep track of which accounts each of these tenants' infrastructure is deployed in. So later on when we go and try to retrieve that application, we can route it to the right spot. And ultimately, we end out with these two accounts that we saw in the last model. And I've also introduced AWS organizations here as well. Because if we're going to spin up new accounts on the fly, AWS organizations is going to provide those tools that we need to be able to do it. And you might have other things like control tower and other things in play here. But this is sort of table stakes to be able to spin up an account per tenant model for this specific example. So I've hinted a couple times at our backend hosting decision for how the infrastructure for the application lives. And I've said, you could host it on your own as a SaaS provider or have the app builder host it. And there's a few factors that I wanted to visit before we kind of close this topic out. Do you want to be building that infrastructure we just looked at? Is this something that you want to operate? Or do you just want to build some webhooks and let the app builder call out to those webhooks? Or do you feel like the tenant isolation should be your responsibility? We looked at some different models we can use. Or do you want to defer that off to the app builder and have them implement that tenant isolation? Are they the type of company that you can guarantee would have the same views on tenant isolation that you might have? And if you do let them, then we still have to build in an API security story, right? They're going to call back to us and they're going to pass the tenant information in. We're going to secure our APIs and say, yes, you can make this call, you can't make that call. We still have some work to do, but we've deferred tenant isolation off to their platform. And finally, the operational story of this is kind of an interesting aspect. We talked about the developer dashboards when we might need to build. But what happens if they're hosting the code? Well, they probably know how to manage logs and metrics themselves. But how do they surface that data back to us? Imagine the case where two applications collide. And now we have to do the operational exchange of where did these logs come from? Do these two different providers have different logs that say different things? How do we troubleshoot these solutions? And so these are some of the factors that come into play in terms of balancing these two solutions out. And they're both viable models. This isn't an either or where you have to pick and say, yeah, that one's no good. We're not going to do app builder hosted. It really is much more about what type of builders you're trying to attract. And as we saw in those two cases, if you're trying to attract builders like you or myself, well, in those cases, you might want to host this on your own behalf because you really can't trust me to host an architecture for all of your tenants and customers. But if you're trying to attract enterprise builders, and that's really a primary key for what you're trying to build for extensibility, then, well, perhaps you can let that host it on their own behalf. So let's switch gears, and I said there's going to be another type of extensibility, and I'm calling this internal extensibility. I mentioned there'd be some differences between how we thought about community apps and how we thought about these internal extensions. And let's dig into some of those differences now, noting that it's not all different. There's still a lot of commonality between these two types of extensibility, but there's a few factors of things that really are different and that we want to manage differently. So these are well-known developers, as we've said. And these well-known developers might have a contract with us, an SOW. We might lay down specific rules about how they can build, how they're going to deploy, their unit test coverage even. So unlike our community apps, where they're simply going to be thrown over the wall to us and we're going to have to figure out how to handle this code, we're going to have more of an ongoing relationship and an expectation that they'll develop within the bounds of what we understand already and what our practices are. And instead of an app marketplace, perhaps the experience is more like feature flags now, or perhaps like entitlement management. And if you're not familiar with entitlements, it's simply a business term for the features that we turn on and off for specific customers. Perhaps in our pricing tier, which features are we going to allow might be enhanced, but what extensions we add to that tier. Our sandboxing story might be a little bit simpler. Instead of thinking about very conservative ways of tenant isolation and how we test this and make sure it sits in front and test before it reaches production, we might have this flow in a more simplified manner because we have the opportunity to test this code and deploy it ourselves. And there might be a shared lifecycle story here. So where we said there would be a completely independent lifecycle of these apps, where they would create the versions and deploy them independently of our version, perhaps there might be some dependencies here now. For controlled industries, perhaps we want to think about whether we want to put these extensions out there between our own releases of our application, and whether we might want to synchronize those things so that our customers have a chance to review those changes and perhaps review them for compliance if that's a requirement of theirs. But there is a similar story in terms of tool sets. And we want to make sure that we're still enabling these developers to focus on the core code that we want them to contribute, rather than the overall undifferentiated heavy lifting of how our platform operates. Do we need to provide them with the authorization flows? Do we need to provide them with an SDK? Is there possibly even a workflow builder experience here? All of those stories could be the same, but again, they could be different, right? There might even be cases where the API isn't the core of what these extensions are calling out to. Rather, they might make direct calls if, in fact, that's the decision we make, even though APIs are always the right way to go. So let's spin up an internal extensibility story now. In terms of what we saw with a community application, we saw how that flow creates a simple application that they contributed to a marketplace. But in this case, we have a SaaS provider who provides staffing solutions for specific industries. In this case, they've already got a strong competency in the travel industry. They know how to deal with ships and airplanes and take a roster of people and staff the right airplane at the right time with the right crew. But they figured their software could be used by some other industries as well. Perhaps hospitals or healthcare. They might be able to use the same type of algorithms that they're using to calculate the staffing of airplanes to staff a hospital as well. But they don't have the expertise or the connections in that industry to be able to gather that data up from all of the different sources that they might live at. But any company, in fact, does. They regularly work with healthcare providers, they're familiar with all of their rostering solutions, and have built translation tools that can take and standardize all of those rosters into one common format. So they want to provide an application, or an extension rather, to the SaaS provider that allows them to translate all of that data and allow the SaaS provider to create a container-based extension that they're going to operate that allows them to take all of this data from these different hospitals and healthcare providers and put that onto their platform and produce the optimized rosters for these SaaS provider tenants who simply want to use these extensions and would think of this as part of the SaaS provider's solution. This wouldn't be an application that they would choose. Rather, if they were in the healthcare industry, this extension would be part of the core offering as they thought about it in terms of the SaaS product. Now, how would we think about this differently in terms of code being contributed from a container-based solution? And that might start from an ECR repository. So perhaps we want to think about a base image that's been signed and hardened. In other words, our SecOps teams perhaps have definitions of what's acceptable for a base image in containers. So they've locked down all of the unnecessary processes in that container. They've signed it to make sure that we can track the origins of that image when it's contributed back to us. Those might be some of the starting points we'd want to think about in terms of allowing this third party, any company, to build this extension. But over time, after they pulled that image, they would eventually have their own image that was complete and ready to be contributed back. We might use ECR again and use a registry policy to allow them to do the cross-account access. We don't have to use an IAM cross-account role in this case, because ECR has its own story for cross-account roles called registry policies. And let's introduce another tool here. We're going to use Amazon Inspector now. And Amazon Inspector is able to scan containers for vulnerabilities. And it can do so continuously based on ECR advanced scanning. So this is interesting because in these cases, these extensions which are contributed by third parties may have vulnerabilities introduced in mid-cycle. Perhaps any company is introducing new versions to us every 6 months. But think of the Log4j scenario we all lived through this year. What happens when a vulnerability happens in between these releases and it's not our core team that's responsible for them? How are we going to tell that team, listen, we've got a vulnerability, we have to fix it right now? And we need a tool like Amazon Inspector that's capable of continually scanning and looking at the vulnerabilities that are produced by any container. So we've introduced this into the flow. We'll have to produce some vulnerability handling here as well. I didn't really get into details on this. We can simply imagine this as perhaps a Lambda that fires off events back to the application developer and says, listen, you've got a vulnerability. And perhaps in this case of this flow, it might block the code pipeline. We might simply say, we're not going to fire off this extension off to the code pipeline if there's a vulnerability, and that might kick this back to the developer as well. But we've got a simple code pipeline. It's going to deploy our container off to Amazon EKS into our test environment first. We might have a manual process here that blocks this as well, but I haven't put one in here, and we'll assume that this will simply proceed to production for now. And again, there's isolation decisions, both on the tenant and compute front, that we have to consider with EKS as well. So one choice that we might have for isolation is to use AWS Fargate. And this is an interesting choice for container-based extensions, because Fargate provides us a level of protection that we don't necessarily get hosting our own EC2s, and that it eliminates the possibility of container escape. So if you're not familiar with container escape, It simply means a process running in that container is capable of escaping from that container and getting into the outer context it's running in. So this is a known vulnerability that could happen with malicious code. So we've prevented that from happening because Fargate, because it runs in a different context, wouldn't allow any escaping containers to attack our core SaaS application. So I really like Fargate for this example, but it's certainly not our only way to isolate these extensions that are running in our system. Another option could be node group isolation. And this simply means we've got our core application, we've got our tenant isolation story running on some EC2s that are running in one node group, but we're going to run our extensions on a completely different set of EC2 instances. So that means any sort of compute conflicts, any noisy neighbor problems are simply going to evaporate. So we don't have to worry about those here because we've isolated the compute. But we could also make it even less conservative and more of a pooled approach here, using namespaces. Now, you've seen namespaces on the first two images here, and I just sort of skimmed over them. But namespaces are a networking construct in the container world, in Kubernetes and EKS, that allow us to keep different containers from talking to one another on a networking level. And we often see this used in SaaS solutions. We use namespace isolation to run two different tenant workloads on the same EKS cluster. And it's a great solution that provides a lot of cost savings and value in terms of optimizing the compute that lives on those EKS clusters. So we're going to use that same concept that we used to protect our tenants from one another to also isolate these extensions, to keep those, from a networking perspective, from being able to talk to tenant containers we don't expect them to. But we have introduced a different problem here. Now there's the potential for noisy neighbors because they're running on the exact same underlying EC2s. So it's a range of solutions. Now, I'm going to say I really like Fargate. I said it in the beginning. That's the one I'm going to choose for implementing this. But all of these are valid solutions. And given the context that we're going to have the opportunity to test these, and perhaps these fall under our same cycles, the same test coverage, the same code testing and operational profiles that we understand of our own application, maybe we take a less conservative approach. And certainly the namespace isolation would provide us the best cost savings in terms of operating our solution. So there's choices to be made here, and of course, trade-offs. So let's look at the end-to-end example of our SaaS provider. So they've got their solution already. It exists in terms of having web apps and phones that can access the solution. And in a lot of ways, it looks like our typical container-based SaaS solutions. There's an ingress that comes in, and the traffic is routed to a login. So you log into this application. We'll say Cognito in this case. And this ingress gateway is going to forward this traffic off to our tenant namespaces, given the context of what was passed in. So we might use perhaps a subdomain. And the ingress gateway would say, this traffic needs to go over to this specific tenant namespace. And if you're interested in what that might look like, we did have a blog this year on using Istio Service Mesh for doing this type of tenant routing. So if you're interested, take a look at that. Won't have enough time to get into all of the details of that, but it's a really neat solution for providing both authentication and authorization and this tenant routing off to tenant namespaces. And as I've mentioned, I do like Fargate for this. So I've decided to implement our extensions in Fargate, decided we probably need to route these as well. All of the traffic coming from our tenant namespace containers is going to have to go somewhere. But I don't want them to know whether they're going to the extension that supports the travel industry or the one supporting healthcare. I just want them to make a call out and say, give me my roster data. So we've implemented a router here that's going to handle that. And it's going to forward all of the traffic off to those extensions. And those extensions, in turn, are going to make calls out to the third-party integrations that they have, whether those be APIs or some other back-end solution that the provider has that gives them those rosters. And we're going to use EventBridge to create this asynchronous barrier to keep us from in any way interfering with the core operation of the extensions and, in turn, our application. So I mentioned at the very beginning that there is something of an operational footprint here that we have to think about. And that's how we're going to manage these extensions. In the app marketplace example, the tenant can turn these extensions on and off on their own behalf. In other examples, we might want to think about other roles that are able to manage these extensions. So let's think of some of the features we might have to build in order to have this extension management in either in a community app solution or for our internal extensions. First and foremost, I'm thinking about the roles that we want to allow to change these extensions. Which of our business units are able to change these? Can our technical roles change these? Can our customer success team change these? And of course, can the tenant change them on their own behalf? And importantly, do we have an audit trail of all of those changes? So from a client and server perspective, because these extensions will control aspects of our UI and our backend, are we able to have SDKs that conveniently allow us to call in and retrieve the state of any specific extension or application, whether it's turned on or off in any of those circumstances? And do we have metadata that's attached to each of these extensions so we can report on them, so we can look at them in an aggregate and deaggregate them and think about what the different purposes of them are? So having metadata is a lot like having tagging in your AWS resources, right? We want to be able to have any number of different tags that tell us what the aspects of something are. And we have to support environments. And this one didn't occur to me right away. It sort of occurred over time as I was thinking about what this might look like. But if you're going to support all of your extensions and apps in one environment, what happens when you have an issue in that environment and need to take that entire environment and copy that configuration back to a dev environment to allow you or I to troubleshoot that environment? What happens to our pre-prod environment if we have a really complicated release that might change a lot of tenant configurations for all of these extensions, and we want to promote that up to prod? Do we have a script that we're going to copy over and run in prod? Is that how we want to manage these? We might want a solution that handles that a little bit more elegantly. And we have to have APIs, just like our extensibility story. APIs are going to drive everything on the backbone of this and allow us to onboard all of any customer that might have extensions or apps turned on by default for them, which we've already said for extensions especially, might be core features for them. And finally, performance. If we're going to rely on some solution that's going to tell us the state of all of our extensions, all of our apps, and perhaps even our core features of our application, we want to make sure that that's performant, and then we have some layer of caching built into that. Because if your SaaS application is going to be configured at runtime, what happens when this solution breaks? And as we always say, everything breaks, right? And then when this breaks, how are we going to make sure our solution from a front-end and back-end perspective continues to perform as expected until that system recovers? And I did start to think of this as feature flags, because we're already using feature flags as SaaS providers. We talked early on about zero downtime deployments and CI/CD. Of course, feature flags are the backbone for many SaaS providers of how they're providing that type of functionality. So we're already using release flags in many cases. We say, okay, the specific flag is going to be turned on, and then for this release, we're going to put the code out there, and we're going to flip it on for tenants once the code is ready to be used. We do experiment flags that allow us to do A/B testing, to allow us to do some specific blue-green tests as well. And those experiment flags and those release flags are all short-lived. We expect them to go away after a while. If they stay in our code, we're going to have a problem. So we go delete all of those lines from our code, we remove those feature flags, and they're gone. But how about a different type of flag? And you remember I defined entitlements before as things a tenant is entitled to use in your system. How about we create entitlement flags, which are longer lived? And they simply flip these feature flags on during a tenant lifecycle event. So the tenant onboards into your SaaS application, and we turn on a couple extensions. And those are long-lived. They'll stay on until some event changes them, like the tenant or one of our business units decides to flip that off on the tenant's behalf. So how could we visualize these in terms of both tenants and potentially tiers? Because when we talk about SaaS pricing, we often bucket these features or entitlements into tiers. We might have to target specific tenants with features. In other words, we want some sort of tag on there that says this tenant is able to use this specific feature. And we might want to group those features together for our tiers as well. And what does that look like? In this case, feature 1 has been tagged for tenant 1 and tenant 28, right? So this is simply more of that metadata that we were talking about. So you have metadata that defines a feature's aspects, in this case, which tenants are allowed to use it. And for feature grouping, we might think of these as a group of features. For our standard tier, perhaps there's only one feature or extension turned on. And for our advanced tier, there may be many more. And as you can imagine, executing these things will require some form of rule engine. You're going to have to be able to say, well, given this tenant context, what are all of the different features they're entitled to? Or perhaps can I ask just this one specific feature as I'm ingressing into a specific application? Is this turned on or off for this tenant? And I started to think about, this is some undifferentiated heavy lifting that we're going to have to build out to support extensibility. And are there already some tools that we might be using in our SaaS platform that would simply cover this use case already? And of course, since I was thinking of these as feature flags, I started to think about how Launch Darkly could solve this problem for us. So if you're already using Launch Darkly to manage your release flags, your experiment flags, we can simply add another type of flag in here for these entitlement flags and use the same tool we're already using for managing feature flags for releases to do our entitlement management as well, or our extension management, if you will. And they provide a convenient UI that allows our business users to be able to go in and change specific features on a tenant's behalf or on a segment's behalf. And a segment maps to tiers. So this is a term that Launch Darkly uses, segments, that nicely maps to our tenant tier features as well. So allowing the business users to make these changes covers one of our use cases. But of course, we have the programmatic use cases as well. Can our SDKs reach out and ask a specific question like, can tenant 1 actually reach this specific feature? Do they have permission to use premium feature 1? And in this case, as you can see, tenant 1 is in our premium group. So they do have permission to reach out and use premium feature 1. And from a code perspective, we simply have to pass in that context. This is the tenant I want, this is the feature I'm trying to retrieve, and they'll give us a yes or no answer. And of course, that same applies for our tenant targeted features. So in this case, tenant 9 has been targeted, and they would be the only tenant allowed to use tenant feature 1. Other tenants like tenant 22 and tenant 27 don't have permissions to use that feature. But tenant 9 does not have permission to use premium feature 1 because they're not part of that premium tier. And as you can imagine, the rule engine that executes all of these different combinations would have to make some decisions on our behalf. So if we were to implement this, we'd have to think about potential collisions, which takes priority over a different rule. And Launch Darkly has that built into its system for us already. Let's go back and revisit the models that we already looked at. We had our serverless app that we built out, and we talked about how we would package it. Let's add the extension manager and feature flags into this model now. Now our Lambda has a tenant manager, and we said it has to decide whether a specific tenant can use the app at this time. So it can reach out to the extension manager, pass that context off to it, and get a yes or no answer, and make a security decision, as can our core API. It can make the same type of decision saying this call is coming in, it's got this tenant context. Is this tenant allowed to access this API or not? And the same goes to our container example. So a new extension coming to our container example could register itself as a feature flag. So listen, we've got this new extension, I'm going to turn it into a feature in Launch Darkly or whatever solution we decide to implement. And then our extension router will make these decisions. Should the specific tenant be allowed to call out to the specific extension? And if something goes horribly wrong, and a tenant is reaching out to an extension that they shouldn't have permission to, like they're trying to reach the wrong industry because we made a coding error, we can use this extension manager to block those calls. And we could also do so at our ingress gateway. We can use the routing rules, which are familiar to all of us who've used ingress gateways, to simply make decisions at the front edge of our application. And say, hey, this call came in for this specific tenant. Should we even let this in the front door? And make the decisions at that stage as well. So for the takeaways, hopefully we've talked enough about growth and thought about the different ways that extensibility can implement growth for us. We've talked about how we can increase our feature set, how we can increase our total addressable market, and hopefully, as a result of those, also increase our growth and our revenue, right? So we've also talked about the developer experience. And one thing we should be constantly thinking about with extensibility is, are the features that we're building for our developers going to make them want to develop applications? And if we removed all of the barriers for developing those applications, remember, these companies that we're inviting to develop on our platform have other ways that they can deliver their product. We want to make this as attractive as possible because this is going to achieve growth for us, and it should also achieve growth for them. From a tenant isolation and a cost perspective, some new dimensions are being added, right? We have to think about our tenant isolation decisions in terms of our tenants, but also in terms of these applications and the compute contexts that they run in. And from a cost perspective, we don't just have to think about cost per tenant anymore. We also have to think about cost per app or extension per tenant. And we have to think about how we're going to manage that data, surface it back up to the business, and potentially serve it up to our app builders and our customers. And finally, this extension management we just finished talking about, we need a plan for it. I don't think that this is simply a table that tells us which features are turned on and off. Perhaps in some simple cases it could be, but I really want us to think about what it means to manage these extensions because they become part of your application from your tenant's perspective. We want them to have a great experience and be able to be uninterrupted. All of those same challenges we talked about tenant experience, about trusting the code, and about our agility are wrapped up in these extensions as well. So with that, we do have some more SaaS sessions. I know it's already Wednesday night, so some of these have gone by, but if you haven't had a chance, please attend some more of these sessions, especially the 400 level sessions. If you want to get down and get your hands dirty, try some SaaS out. We have EKS, microservices, and serverless workshops. Those are excellent. Even if you have to go stand in line, I would definitely recommend it. We've got some more sessions coming up, including SAS304, solving the compliance puzzle on Friday. If you're brave enough to stay all the way through Friday and wake up in the morning, this is the next session that I'm giving. I'd love to see you guys there. And then finally, we do have some QR codes here for some more SaaS information. I'll come back to this slide after the thank you slide so you can download it if you want to. But finally, I do want to say thank you. I really appreciate you guys coming out this late. I think this is a great topic. I'm looking to explore it more. Please fill out your surveys because they do influence what's going to be here at reInvent next year. So I love the fact that we are able to vote with our feet and say which topics we like and what we want to see coming back again next year. I'd love to explore this topic more and come back again next year and talk more about it. Thank you all very much. Have a lovely evening.